data type conversions. We were here. The data type conversion is sometimes useful. So if I want to extract, I think this previous one was this. Yeah, that was the example. I can use the conversion to extract fractional part or whole number part from a number as needed. So we went over that example. So let's look at another example. Float sal int num, and then sal equal to 34.723, num equal to sal, sal equal to num, and then C out sal. Now, can somebody figure out what will be printed here? Exactly what number? Remember,
34 will be printed with a decimal point.
with the point, yeah. If there is a point, you have to mention that. The point, decimal point matters in computer science. So one student answered 34 point. Anybody else? Okay, 34 point is right. Because the 34.723 is what Sal has. And when you copy it into num, you're going to get 34 because num is integer. Then you copy the 34 back into Sal. Since Sal is float type, you will get a decimal point added. So Sal now has 34 point, and that's what that's going to print. Okay, so moving on to conversion between char and int type. Okay, so when we went over the decimal codes and ASCII codes of characters, I explained that character A, uppercase A has a code, binary code, which is, ASCII code, which is same as binary code of 65. Uppercase A and 65 have same codes. Binary code of 65 and ASCII code of A are same. So therefore, 65 is said to be the decimal code of A. So every alphabet has a decimal code. Every symbol, all characters we use have a decimal equivalent. And so when you write a program, if you end up converting a integer to character or character to integer, it will convert them this way. A will be converted to 65 if you convert A to integer. If you go backwards, 65 will be converted to A. So every alphabet has a corresponding decimal code, and that decimal code is what you're going to get if you convert it to integer. So how do you convert it to integer? By assigning it to an integer variable. So let's look at some examples. If I convert A to int, I'll get 65. If I convert 65 to character, I'll get A. And to do the conversion, you will be just assigning to that type of variable. We're going to see examples now next. So here is a example. Char val1. So val1 is a character type. And then val2 is integer type, and I'm storing 65 in it. After that, I copy the val2 into val1. Val1 is character type. So therefore, the 65 that is stored here is being converted to character. So val1 will have capital A. And we are printing it, so character A will be printed. So whatever the data type of the variable, that's the type of the value you're going to have. So even if I do it this way, let me explain on the board now. The val1 is char type, right? Even if I write a simple statement like this, char val1, and then assign 65. It doesn't have to go through all those statements. So what is going to be stored in val1? character A. Okay, it's not 65. The 65 and A are same. So in the memory, they look the same, but it will be recognized as character when you declare the variable as character. So if you now print it, print val1, then you're going to get A printed. So let me write another example. But if this was declared that it's int val1 equal to 65, then you'll be printing 65, not character. Okay, let me write another example. Let's say I do int val equal to character A. Now, when you're assigning character value A, you need quotes around it. Okay, and then I see out val. Okay, what will be printed? Anybody?
65.
65. That's correct. Because I converted the character to integer. Okay, so that's how it goes. So next example, example 5 says int num1 char ch1 equal to b. So ch1 has b stored as is, and then num1 equal to ch1. Here I'm copying the character into num1. So num1 will have integer or decimal equivalent of b, which is 66. So see out num1, that'll print 66. All right, so these are exercises. I want you to do them quickly. Remember, if the answer is going to have a decimal point, you need to mention that. You need to include that in your answer. What will be printed by these? I'll give you a few seconds and then I'll start asking. Okay, anybody see what will be printed in part A?
32.
32 is correct. Okay, part B.
5 points.
5 point is correct. Very good. Part C, there's a division. 7.0 divided by 2.0 will be 3.5. What will be printed?
3.5.
3.5 will be printed correctly, yes. Part D, char val equal to 99.
99.
No, this will not print 99.
It will print the character, right?
Yes.
Yeah, with the apostrophe, right? The quotes.
No, not really. 97 corresponds to lowercase a, 98 is lowercase b, 99 is lowercase c. Okay, so lowercase c will be printed. Remember, the uppercase characters correspond to 65 to 90. Lowercase alphabets correspond to 97 to 122. That information you need to be able to answer these questions. And so you can look up on your book, it's in the appendix, the full detail is there. In a test, it will be given. These codes will be given to you, the decimal equivalents. So 99 is lowercase c, so this will print lowercase c. Part E has a division, 25.8 over 3 will be 8 point something. Let me give you the accurate number.
8.6.
8.
We're dividing by 3, okay. Okay, so what will be printed again? The answer of the division, val over m, will be 8.6. 25.8 divided by 3 is 8.6. So what will be printed?
8.
8 will be printed, right. Very good. Because the variable n is integer. So the result of the division will be converted to integer, which will be 8. So you'll only get 8 So problems like this are in your homework. Very simple, but you had to pay attention to the conversion going on. Only then you will get it right. Also, I mentioned to you before, the odd numbered problems have answers in the back. Even numbered problems are very similar to odd numbered problems. So if you practice, if you always do the odd numbered problems and compare the answer before doing the even problem, then you are more likely to get the even numbered problems right. You're likely to get better grade in your homework. So you may want to do that. Okay, so let's look at applications of data conversion. So these conversions are useful. I gave you one example of use of such conversions. There are more, and we're going to see some more. One application is printing the whole number part. In other words, you want to drop the fractional part and only get the whole number part. All you have to do is assign the value to an integer variable. So here's an example. The two numbers we are dividing are float, and we are dividing here, and the result is assigned to integer variable. That way, we are only getting the whole number part of the answer, and we are printing that. That's one application. The other one is rounding. I'm going to have to explain that. The system is never going to round any number for you. It'll just give you all the digits. When you do some division or any arithmetic operation, the result will be given to you as a fractional number with many fractional digits. Sometimes we don't want all that. We want the number rounded to one decimal digit. That means like 5.6. I don't want 5.5978231, all those digits. So if you want to do that, you're going to have to write statements to achieve that. The system is not going to help you with that. This rounding business I'm going to talk about next is important whenever you need to limit your fractional digits in your answer. So let me clear the screen, and I'm going to explain on the board exactly how to round a number. So my example here is to round a number to the nearest nearest integer, numeric rounded, yeah, nearest integer. So this first example is rounding answer to the nearest integer. Let's say our variable val has a number that has many fractional digits like this. I'm going to use an example. Let's say it's 7.6 4, 8 to whatever, many more digits can be there. So val has this value already stored in it. And what I want to do is I want to replace it with rounded nearest integer, which will be 8. So if the value is 7.6, rounded number will be 8. If the value is something like 7.4, 8 to all those, then rounded number will be 7. So how do we achieve that? So we have to write statements to achieve that. It will give you the number as is if you just print it. So here is how you do that. If I add the technique of rounding to the nearest integer is to add 0.5. So if I add 0.5 to val, then what happens if the number is, let me write here, if the number is 7.6, adding 0.5 7.6 plus 0.5 becomes 8.1. And if I take the integer part, that's my rounded number. If the original number was 7.4, if whatever the technique is, it has to work in both cases. When the digit after decimal point is more than 5, the 7 has to increase to 8. If the digit after decimal point is less than 5, the number should should be same as original integer part. So 7.4, if it was 7.4, then when I add 0.5, it'll be 7.9. And if I take integer part, it'll be 7, which is correct rounded number. So that's what we need to do. So if I'm just printing, let's say I just want to print a rounded number, then I can say val equal to, I can use another number, in type variable m equal to val plus 0.5. So what's happening? 0.5 is added to val. So if the val was like 7.6, now I have 8.1. If it was like 7.4, now I have 7.9. And then I'm assigning it to integer variable. So that'll pick up integer part, which is rounded number. So I've finished my rounding right there. I rounded my val to the nearest integer. I have put it in variable m. So now I can see out m, and that'll be rounded number. So that's if I'm rounding for printing purposes. So let me, 1 second. Let me clear this part of the board. And instead of printing, so these two statements will be able to print rounded number for you. But some questions will ask you to replace the original value, original memory cell val, with a rounded number. So that will require some additional statements. So, so the question I'm answering now is replacing the original variable val with the rounded value, rounded in number, rounded to the whole number, that is. Okay, so I can still do this first step as is. So the one I'm doing right now is to replace. If the question says write statements to replace, my pencil is not working very well today, sorry. Replace val with rounded value. Okay, then I still have to use a in type variable m and write val plus 0.5. And so now m has the rounded number. So, but the original val still has the same number it originally had. So the val now has to be replaced. So I say val equal to m. So that will replace val with the rounded number. Now, notice that the val will have the rounded number with the decimal point. That's okay. The number needs to be rounded. Since val is floor type, it's going to have a decimal point, but that's okay. Still, it's a whole number, and that's what it is. So what if you want to do it for a fractional part like this? What if I want to do the rounding, but I want to do that for a portion of another digit, like first decimal digit. So let's see, let's say val has 7.6 or 7.4. No, those are bad examples. All right, let me use a different number now. We want to round it to the nearest 10th. So basically, I want to round it in this first decimal digit. That means if the number is like 7.49, then it should be 7.5. Instead, if the number is 7.44, then it should be 7.4. So I want to round it to one fractional digit, this right there. So the process is very similar. All you do is, let's say the val is the variable name. What you do is, we need to move this decimal point behind this. After that, it'll be similar to what we did before. So you take the val, whatever the val has, you multiply it by 10, then the decimal point goes behind it, behind the 4, and now it becomes 74.9. After that, if I add 0.5, then I'm rounding at this digit, it'll become 75. So I take that and divide it by 10. I have to move the decimal point over. So let me show you the numbers again. 7.49, when I add 0.5, it becomes 7. I'm sorry. When I convert it to, when I multiply by 10, it will become 74.9. Now I am adding 0.5. Now it becomes 70.5, and then I have to store it in an integer variable. It becomes 75.4 when I add this, 75.4, right? So if I store it in an integer variable now, int m, then I pick up only the 75. So m has 75, but the correct answer is 7.5. So I need to divide back by 10. I multiplied by 10, now I have to divide by 10. So if I take the m and divide by 10, you have to divide by 10.0, which I will explain, which we will understand why later. And then assign it to m, not m is integer variable. So assign it to val. Now val is replaced with the rounded value. So how do we do it? One more time. Multiply the current value by 10, then it becomes 74.9. If I add 0.5, you're rounding at this decimal point now, and it'll become 75.4. And then take the integer part, that'll become 75. And then divide by 10 to make it 7.5. You need the decimal point, so that's a rounded number, rounded to the nearest 10th. This right here is the statement to replace val with rounded number rounded to nearest 10th. So these are some of the uses of the conversions. Moving on.
So I have a question.
Yeah.
This doesn't seem very intuitive. Like 4 steps to round the number to the nearest 10th. Is there a way to do this without these steps?
No. So that's the thing, if you want to get numbers rounded, this is what we have to do. Now there is, much later in the course, we will learn a way to print the answer rounded using some other method without having to go through all this. That's only good for printing. When you're printing, you can say, this is what I want to print. And so you can ask for the rounded number to be printed. But if you need to replace the original memory cell with rounded number, there's no other way. This is the only way, what I have shown here. So yes, it requires a little bit of thinking and figuring out. So if you're rounding at this 10th digit, you need to multiply by 10 and then add 0.5, take integer part, then divide by 10 to bring the decimal point back. You move the decimal point, I had to bring it back. So it's just two statements right here. So that's the only way. Okay. So yeah,
So I just put where is it? Rounding a number example. I put that into Xcode and I got 0. Is that right?
what you mean?
Float n1 equals 17.6 and 2 equals 5.2.
You mean you're using some kind of rounding feature from the C++, Xcode C++?
No, I put that code into Xcode right now and I got 0.
Oh, that's because you don't have any value in val. You have to store something in val first. This is explained here, assuming val has some fractional number. These two statements will replace val with the rounded number rounded to nearest 10th. Okay,
Mhm.
you can store some value in val and then run this to test it out. I'm moving on to understanding. You can try that later and bring up question if you find it not working. So these, we went over these arithmetic operations before, and we need to add one more operation. So I'm going to go over all of them again. Plus operation for addition, minus for subtraction, asterisk for multiplication, slash for division. These are the operators we learned. Now there is one more operator, modulus, I'm going to explain next. Now, this is an example. We have done examples like this before, so I don't need to go over that. So let's, yeah, we'll go over the modulus operator in a minute. But this one, the value of the expression can, if you have an expression on the right side and a variable on the left side, then the expression will be evaluated first. This expression will be evaluated. So here in this case, x is 3. So x times x is 9 plus 6, 15. The 15 will be stored in y, but y is float type variable. So it'll be 15 point. When you print it, the value will be 15 point. Now, the point I'm trying to make here is sometimes when you print it, the system doesn't write the point because there's nothing behind it, but still the number is actually 15 point. Okay, so when you are writing output for this program, if I give you this program as a homework problem and ask you what will be printed by this, you must say 15 point. The decimal point must be there to be right. If the point is missing, it's wrong answer. All right, so going on to modulus operator. Modulus operator is applicable only for integers. So if I write m modulus n, where m and n are integer variables, then this will produce the remainder of dividing m by n. So here is an example. M is 23, n is 5. Then m modulus n is the remainder of dividing 23 by 5. So that means I'm doing on the board now. If I divide 23 by 5, 23 by 5, 5 goes into 23 4 times, and the remainder is 3. So this remainder is the value of m modulus n. So this cout k will print 3. K has a 3, the remainder of the division of m by n. So it is a operator that produces the remainder of the division. And why do we have this? You know, this is something you don't have in math, right? It is a useful operation in computer programming, as you will see later.
Is that a way to find hexadecimal code?
Yeah, the not only hexadecimal code, binary code, all those require the remainder. Yeah, you can say that that would be one application for manually I mean, you know that system will automatically convert your number to binary code if you declare if you store the number in a integer type variable. But if you want to manually convert, you need to find the remainder. So this will be helpful. But there are more important use of this modulus operator coming up in the next page. So let's look at some examples. 35 modulus 2. 35 modulus 2, 2 goes into 35 17 times, but 17 times 2 is 34, so remainder is 1. 34 modulus 2 is 0. So notice that if I divide any odd number by 2, my remainder will be 1. If I divide any even number by 2, remainder will be 0. All right, so let's that's important. That's it's coming up. That's one of the applications. 17 modulus 2 modulus 4. If I write something like that, that means you need 17 modulus 10 first. The value of 17 modulus 10 is, anybody? Just the 17.
7.
7. 17 modulus 10 is 7. And now 7 modulus 4 will be 3. 4 goes into 7 one time with the remainder of 3. So you may have this operation multiplying in an expression. The modulus operator can be there more than once. Okay, so do this exercise. A is 33, B is 7, C is 2. Find the answer for this. What will be printed? Determine what will be printed.
3.
Okay. Nope, not 3.
One.
1 is right. Very good. A modulus B will be done first because it's in parentheses. 33 modulus 7. 7 goes into 33 4 times with the remainder of 5. So the value of A modulus B is 5. So now we are doing 5 modulus 2. 5 modulus 2 is 1, because 2 goes into 5 2 times, remainder is 1. So this will print 1. All right, so now let's see the application. We just saw that in the previous example, that if n is a even number, n modulus 2 will be 0. Any even number divided by 2 will be 0, clearly. But if it is odd number, then when you divide by 2, your answer will be not 0. It'll be 1 actually. When you divide by 2, it'll be the answer. The remainder will have to be 0 or 1. The remainder has to be always less than the dividing number. So it has to be 0 or 1. When the number is even, it'll be 0. When the number is odd, it'll be 1. So that means this is useful to determine whether a number is a even number or odd number. So just do the modulus with 2 and see what number it is. So if the n modulus 2 is 0, then it is even number. N is even number. If n modulus 2 is 1, then n is odd number. Another use of that modulus operator is, for example, to determine the last digit of any number, any integer. So let me use an example on the board. Okay, the number 357. So let's say M has this number, N has 43. I can extract the last digit of whatever the value M has. So M has 357, last digit is 7, right? How do I get that? Just do M modulus 10. M modulus 10 means divide this number by 10. So how many tens are there? 35, isn't it? There are 35 tens, but 35 times 10 is 350, so the remainder is 7. Everybody see that?
Yeah.
Yes.
Yes. Yes. So if I want to print the last digit of the number stored in M, I see out M modulus 10. That'll print the last digit. It'll work regardless of what the number is. If the number is 43, then still, when you divide by 10, 10 goes into 43 4 times, with the remainder is 3. Even if the number is 7,564, 10 goes into this number 756 times, with the remainder of 4. So dividing by, taking modulus with 10 will be a way to extract the last digit. Okay. All right, so one exercise I would give you next is M has some integer. This is only applicable to integer. Remember, modulus operator can be only used on integers. So M is an integer variable. It has some number in it. I want to extract the last 2 digits. You can assume that the number has more than 2 digits. So how do I print the last 2 digits? Anybody?
Are you asking?
Yeah, my question is, like if M has 357, I want to print 57, last 2 digits,
Oh, you do modulus 100.
100. That's right. M modulus 100 will do it. Okay, now we'll do the warm-up exercise here on the screen. Write C++ statements to extract and print the second digit from last. That means, for example, if the number is 7564 like this, you want to print the 6, this number, second digit from last.
So at first you have to divide by 10 and then module 10.
Okay,
So
that's one. Yeah, there are many ways, and that's one way. Okay, so let's go over that method. 7564, I'm using this as an example. You said divide by 10, right? Okay, divide by 10 and take the integer part of it. That'll be 756. Right, is that what you said? Divide by 10.
yeah, and then module 10.
Now
So
take modulus, right. Now take modulus 10. That'll give you 6. That's right. That's one way. Another way is from 7564, you can take modulus 100. That'll give you 64, right? And then you divide by 10 and take integer part. Divide by 10 and take integer part, that'll be 6. So there are different ways to do something. So in your homework, if it asks you to do something like this, whatever method you come up with, you can present that as your solution. Everybody follow this, or should I explain that? All right, let me write the statements to do this. So M is an integer variable that has some integer in it, and we are trying to extract the digit before last. So what we can do is, we can do, if you are allowed to erase the original value of M, then we'll put this new value in M. If you're not allowed to do that, then you can use another variable. So I'm going to use N, in which I'm going to have the digit before last that M has. This is M. M has some number in it. So N will be equal to M modulus 10, 100 that is. Okay, if I do that, then that will extract the last 2 digits. And so now what I need to do is divide M, the new value of M, no, the value of N, this variable, by 10, and assign it back to N. Now N has 6, because this M has this number, because when you divide by 100, the remainder is these 2 digits. And then if you divide by 10 and take integer part, that'll be picking up 6. So that's what I did. So these two statements will extract the digit second to last.
You said divide by 10?
Yeah.
Divide by 100?
No, first I did the modulus with 100,
Okay.
and then I divide by 10. The modulus will produce remainder. So modulus with 100 will produce 64. 64 is the remainder when you divide, when you do modulus of this number with 100. You follow that, right?
Yeah.
Yeah. And then that 64, from that 64 to extract the 6, I have to divide by 10. If I take modulus with 10, I'll be getting the last digit, 4. I don't want that. I divide by 10, then that'll become 6.4. And I'm taking integer part of that in n, which is 6. Okay, does that make sense?
Yes.
All right. So this kind of modulus and division can be combined to extract any digit from a large number. And questions like that will be in your homework, in your test, so you have to be prepared to handle things like this. Okay, memory allocations. By the way, let me remind you, when we finish this chapter 2, we are going to have the test. And there is a practice test already posted on your supplements. So you may want to start working on that. There will be a class allocated for discussing questions from that practice test, but you have to do them first and bring up questions. So it is likely, today is the 6th class. I think 9th or 10th class will be the test. So it's not far away. So memory allocations, we learned earlier that we can declare the variable with the keywords char, int, and float. So if I declare the variable as char, then I'm saying the variable will hold character value, and a character requires only 1 byte of memory. You only need exactly 1 byte for each character. We discussed that in chapter 1. So therefore, if you declare a variable as character, it will allocate 1 byte of memory. What we call memory cell would only have 1 byte in that case. But if I declare the variable as int type, then the memory cell allocated to that variable will have 4 bytes. The system has been already instructed to do this. And if I declare a variable as float type, it'll again give you 4 bytes, because numbers can be very large. So we have to allow large numbers, and that's why it gives you 4 bytes so that you can fit any number, any size number. Still, there's a limit to what you can fit on those 4 bytes. And we will be calculating those limits as we proceed. Char type means only 1 byte of memory will be allocated. So here's an example. If I declare a variable as int num, then num will have 4 bytes of memory allocated for it. So we will still identify the variable, the memory cell as with a box. So we still draw a box, but the box will have 4 byte long memory. So the box I use for num actually has 4 bytes. If you declare as char, then it'll be only 1 byte of memory. So it's those numbers you're going to have to remember. It's not that hard to remember anyway. One other thing you need to remember here is, even though int and float are getting same amount of memory, the float is considered to be larger data type. So we need to know what data type is larger than what for conversions that we are going to learn in the next section. The conversions happen during arithmetic operations also, and that conversion will depend on which variable is of larger type. And that's why you need to know which is larger than which. Int is larger than, usually they're going by the size of the memory allocated. So between char and int is larger because int gets 4 bytes. Between int and float, they seem to get same amount of memory, but float is considered to be larger. So float is larger type. That's something you will have to use later on. So now we are going into type conversions during arithmetic operations. The data type conversions happen not only when you assign. We have been learning about conversions happening during assignment, like this. Int, if I'd say int m and then assign 6.7, then I'm converting 6.7 to integer, so m will only get 6 in it. Things like that are called conversion during assignment. Conversions will also happen in arithmetic operations.
Professor,
Yeah.
isn't it in integer m? Isn't it float because the 6.7 is a decimal?
Yes, you need float type if you want to store 6.7 as is. Yes. So yeah, if I ask you to store 6.7 in the memory, then you do have to declare a float type variable and assign 6.7. I agree with that. But what if you assign it? If you assign it to an integer variable, what will happen? It'll work. This assignment, this statement is valid and it will work. And what will happen is m will only have 6 in it. Understand?
Okay.
Those are conversions we discussed.
Yeah.
So you may have forgotten that. And also, if we declare a float type variable and assign, m, and assign a number like 5, then inside the memory cell, what is stored there?
5.
No. M
5.0,
5 point. Just
5
point.
point, yeah, 5 point.
If you put 0 behind it, you normally we put 0 behind it to highlight the decimal point, to tell the reader that there is decimal point here. But even if you don't put the decimal or the 0, 5 point will be correct answer. Okay. But if you write 5, that's wrong answer. Remember that. You're doing homework on this. So your answer has to be either 5.0 or 5 point.
Okay.
All right, so the conversions happen. This was discussed in the last class, at the beginning of last class. So at the end of last class, sorry. So conversions happen when you're assigning. When you assign a fractional number to integer variable, only integer value, integer part of the number will be picked up. When you assign whole number to a float type variable, the number will be converted to float type by adding decimal point. Those are the two things we discussed before. Similarly, today we discussed, if you assign an integer to character type, then it will be converted to character. If you assign a character value to integer type, the character will be converted to integer. When you do that, the decimal equivalent is the number you'll have in that memory. So those are the conversions we learned for assignments. So those are conversions happening during assignments. Now, there is also conversion happening during arithmetic operation. So after you learn this, you're going to have to pay full attention to any expression to get the correct value for the expression. We're basically learning how the computer will calculate our expression. Only if you understand how the computer will handle our expressions, we can write the expressions correctly. This type conversion during arithmetic operation. To understand that, I'm going to start with a simple example. 3.5 times 2. If I multiply 3.5 by 2, the result is going to be what type is the question. The question is, if I multiply two numbers, the system has to know what type of answer is going to come out before it can do the operation. So if it is 3 times 2, then it's, we can instruct the system that If you're multiplying integer by integer, the answer will be integer. And if you're multiplying 3.2 and 2.5, then both are float type numbers. So if you tell the system if both numbers are float type, then the answer will be float, then that'll be fine. The system has been already instructed that. So when it's doing a multiplication or any operation, it needs to know what type of value will be produced. So only then it can carry out that operation. It needs to know what type of value will be produced so that it can store that value, store the result in the correct data type. So therefore, system has been instructed this. If both are integers in any operation, then the result will be integer. If both operands are float in any operation, not only the multiplication, also division, addition, subtraction, in all the operations, if both are float, then the answer will be float. Very simple. So only problem is when they are mixed, float and int, what would be the type? In this case, the answer is a whole number, but it's not always a whole number. It can be a fractional number, right? Like 7.2 times 4 is a fractional number. So what should we tell the system? The result of multiplying two numbers, if they are mixed type, one is float and the other is int, then what would be the right data type for the answer so that we'll get the answer right? In order to get the answer right, we had to instruct the system that the answer will be float type, even though sometimes it'll be whole number. Float type will be the best, right? Otherwise, you know, see, this product is a float type number. If I say the result will be integer, it's not going to give me the full answer. It's going to give me only the integer part of the answer. So therefore, the right thing to do is to put it in a float type memory. Put the answer in a float type memory. It needs to know what type of memory the answer will go to. So that's exactly what the system has been instructed. If both data types are same, like in the int or float, then the result will be of the same type. If they are mixed, like this, then the result will be float type, the larger type. Not float type, it should be larger type, because you may be multiplying others data types, not only float and int, there are other data types also. So it has been instructed to convert both of them to larger type and produce the larger type answer. So if it is doing 3.5 times 2, the system will convert both of them to float type first, 3.5 times 2.0, and then it will produce 7.0 as the result. Even though it's whole number, it'll have a point behind it. It'll be float type answer. So that's the instruction system has been given. So I have highlighted that information right here. There are two operands for any operation, which can be of two different types. The result of the operation has to be one type. So therefore, the system has to determine exactly what that type is. And here is the rule. Here's the rule at the bottom of the screen. If both operands are of the same type, the result will be of the same type. If one operand is float and the other is int type, the result will be float. But more generally, the result will be always the larger type of the two, the larger of the two. So in this case, between float and int, float is larger. So both of them will be converted to float, and then the operation will be carried out. So 3.5 multiplied by 2 will be 7.0 float type number. Okay, so that's a simple rule, but it applies to all the arithmetic operations. Now, obviously, it'll work fine, right? 7.0, if 7.0 is printed as answer, that's acceptable, right? It's a whole number, but it has a decimal point behind it. And same thing happens if you're adding. So if I'm adding 3.5 and 2.5, the answer is a whole number, right? 6, but what will be produced exactly? Can somebody tell me?
6 point.
6 point will be the actual answer produced, because both numbers are float, so the answer will be float. Now, even if you add 3.5 to 2, a whole number, it'll be 5.5 float type number, 5.5. So for any operation, it's going to do the same. So it's fine for all the operations except for division. This rule that the system has been given works fine for all the operations except for the division. When it comes to division, it's a problem.
I'm sorry, Professor, before you continue, could I ask a question about the previous, the rules of arriving for the results of an operation?
Yes.
So if you declare a variable as an integer, for example, and then the expression on the right side for that variable would be, for example, a capital A plus a 1, would the variable be equal to 66, right? Since the ASCII code of the capital A is a 65, would that transfer to an integer, or would it stay as a character and be invalid?
Okay, I think let me write on the board what you're suggesting. So
Sure.
you're basically saying if I declare a variable as int type,
Yes.
so let's do that. Int type n, right? And then assign a capital A in quotes plus 1, did you say?
Yeah, sure. Just
Yes.
because, so a capital A, right, is a 65 in the ASCII code.
Yes, yes, good question. These are actually coming up later.
Okay, sorry.
Basically, you're adding a character value to an integer. So the character and integer, the integer is larger type, right? So remember, integer has 4 bytes, character gets 1 byte, so therefore integer is larger type. So it will convert both of them to int type, and therefore this will become 65, and this will become 1. Now it'll add those, okay? So the result is 66. And if you store it in int type variable, it'll be 66. If you store it in char type variable instead, if you make it char, then it'll convert the 66 back to character, which will be B, capital B. So that is.
So it would convert the 66 into a character. It wouldn't convert the 1 into a character and then add that to the A as a character.
It won't. See, I just
Okay.
explained. It'll look at this arithmetic operation first. It doesn't look at a type. It doesn't look at the left side at all. It'll do this up. Look at the operation. One is character, one is int. So it'll convert both of them to int, the larger type.
Okay.
That'll be 65 and 1. Then it'll add them, 66. Now it'll be assigning to the left side. Where the left side is integer type, and then 66 will be stored as is. If the variable on the left side is character type, it'll be converted to character and stored in n.
Okay. Yeah, I got it. Thank you.
So there's a lot of conversions going on. That's exactly what you need to focus on. So we're going to have more of these type of examples coming up later. So look at this example on the board, example 10. If m is 5 and n is 2, they're both integers. So according to the rule given to the system, if I divide m by n, then I'm dividing 5 by 2. If both data types are integers, then the answer will be of the same type, right? That's the rule system has been given. So since both are integers, the result will be integer type. The correct value is 2.5, but it's going to give you 2 because you said system can store the answer in an int type variable. So that's what it'll do. So therefore, the answer you get will be 2, not 2.5. So the division, the rule that system has works for all the other operations correctly, except for the division. So when it comes to division, it's going to produce wrong answer. But there is a way we can avoid this, avoid getting wrong answer. We're going to discuss that in a minute. But we are understanding right now what will happen if you just go ahead and do this. So let's say I'm doing this, float A equal to m over n, where m and n have been integer variables. M equal to 5, n equal to 2. So that's, the left side is float. That's not going to help. M is int, n is int. For the division, these are both integers, so it will only produce 2 as answer. So when the 2 is assigned to float type variable A will get 2 points. That's still not getting us correct answer, right? Correct answer is 2.5. So yes, it will produce wrong answer for the division. And same thing with the n over m. N over m is supposed to be 0.4, but it'll give you 0. Only the integer part it'll give you because it's following the rule. So is there any way we can get the answer correctly? Yes. What we have to do is convert one of them to int, one of them to float, like this. If you make the m float type variable, then when you divide m over n, m is float, so therefore result will be float. So it'll be correct answer now. So you can make them both float if you like. And then it'll do the division right. So let's say I make both m and n float. Then this division 5 over 2 will produce 2.5. But then if I make the s integer, I'm only picking up 2. So if I want the correct answer stored, then s has to be also float if you want the correct answer. Okay, so make one of them float. Or if you are doing division like this, a quick example on the board, if I say float.
Professor, it's 9:16. We have already gone past our limit.
Yes, I understand. Just Jeremy, just finish this. Even if I write 5 over 2 in this like this, just the fact that x is float is not going to help you. 5 over 2 integer divided by integer is integer. That's a 2. And the 2 will be converted to float type, and the x will have 2 points. Still not correct answer. Okay. So how do I make that work right? I can change the 2 to 2.0. Just put a point behind the 2, then it'll be correct. Okay, I just wanted to finish that topic.